Okay, I've spent the past hour or so looking back at exam one from the past couple semesters, and I've been looking at stuff that students haven't done well on. And frankly, students haven't done as well as I've wanted them to on this exam. So right now, I'm going to break down for you some stuff that your predecessors haven't done as good a job on as they could have, and apparently, didn't understand as well as I wanted them to going into the exam. Because a lot of folks miss questions on these topics. So let me see if I can straighten you guys out a little bit before the exam. I'm not doing this on PowerPoint. I'm doing this on my cell phone and a piece of paper because, frankly, I'm tired of PowerPoint and stuff like that, and just kind of trying to keep it simple here. So the first thing that students have had a lot of trouble with is understanding what type of statistical process control chart to make in different types of situations. And I think this is just generally important. Business, there's a lot of good tools, but a lot of times understanding which tool to deploy in a particular situation is really a critical thing. Picking the right tool from a bunch of good tools. So let's talk about how to pick the right tool in this type of situation. So there's really like two types of kind of bad quality. Okay. Um, uh, One is what we call stuff that can be measured by attributes data, and the other type is what can be measured by variables data. And when we've got attributes data, we're going to make a P or a C chart. What do I mean by attributes data? By that, I mean stuff that you can only count, okay? You can't measure it. All right, like a customer complaint, you can just count how many complaints there were yesterday, right, or the past hour, or whatever. You can't measure a complaint. You can't say, well, that complaint weighed 5 pounds, or that complaint was 6 inches long, right? You just can't do it, right? Or if you're just counting the number of times that you missed class last month or something like that, right? You can't really measure it. Either you missed it or you didn't. It's binomial, right? So you can just count that stuff. Okay, so the other type of situation is when we can measure things, right? Like we may say, you have to answer the phone within, 30 seconds of when the customer calls, right? And, we could actually measure the amount of time it takes you to, to answer the phone, right? And we could chart that data, right? We can measure that in minutes, right? Or we might be concerned with, how many potato chips our machine is putting in a bag, right? We can measure the amount of potato chips in, grams or ounces or whatever, right? We're running a coffee shop, we might measure the temperature of the hot water that's going into the machine, or we might measure the temperature, occasionally of a cup of coffee that before we serve it to a customer, right? We can measure that in degrees, right? So the real key here is the difference between counting and measuring. Okay, if we're measuring, we're going to make an X bar and an R chart. We always make those together, right? So that's really kind of one situation. And we have two situations here where we count either a P chart or a C chart. So what's the difference? Okay, sometimes, I think a different way to say this that I really haven't talked about before is if we can compute a ratio, we're going to make a P chart, all right? If we can't compute a ratio, because in a sense there's like no denominator, we're going to make a C chart. All right, so if I just counted up like the number of complaints, number of customer complaints that I got every day, or in a day, or in an hour, it doesn't matter, right? That's just a number, right? I can't really do anything with that number. I can't really divide, right? And again, if that's a situation, that would be like we'd want to make a C chart, right? Because we can't compute a ratio. What do I mean when I say we can compute a ratio? Well, what if we take a sample, okay, and within each sample we just say, the each unit in the sample either passes or fails, right? So, we could take a sample of let's say M&Ms, coming off a production line, right? Every hour we take a sample of 100 M&Ms, and for each M&M we either say, it passes or it fails, right? And maybe in the first hour, 10 out of 100 um, M&Ms fail, let's say, and the next hour we take another sample, and 5 out of 100 M&Ms fail. Why do they fail? I don't know. It's not important. Let's say the company just has some different criteria. The coating's not the right thickness, whatever. It's cracked. The point is, we're taking a sample, okay, and we're saying for each unit in the sample, either it passes or it fails. Now we can compute a ratio, right? Here it's 0.10 or 10%, right? Here it's 0.05. Okay, because we're taking a sample, we have a fixed number of opportunities to make a defect, right, within the sample. Okay, whereas up here with complaints, we can't do that. If I told you there were 12 complaints yesterday, but that's all I told you, you can't compute a ratio, right? Because there's no denominator. You don't really know how many opportunities there were, for there to be a complaint, right? I mean, that's silly. You can't compute that. Okay, so again, if we've got a situation where we can compute a ratio, and typically that's like good, bad, yes, no, passes, fails, right? We're going to make a P-chart, okay? I know I'm wiggling my phone around here like crazy, but that's okay. If we can't make a ratio, we want to make a C-chart. All right. And again, these are both situations where we just have defects that we can count, right? We can't measure stuff. Again, if we're in a situation where we're dealing with something like temperature, length, weight, and we're actually measuring that, right? The average cup of coffee, or this particular cup of coffee, is 95 degrees. This thing is 6 inches long. This thing weighs 2 ounces, right? The next thing weighs 2.5 ounces. We're measuring stuff. In that situation, we're always going to make an X bar and an R chart.